Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. I hope everyone is doing fine. We're supposed to take this session online on 5 June, but actually we faced some issue. So regarding to that, we decided to take this session as to be online, and it will be recorded, and we are going to upload it for the Google Classroom, and anyone here can join and watch these sessions. So everyone feel interested to learn about solar system sizing and design. So you have to keep in mind there's two types of engineering, especially in the solar. There's the site engineering and there's designer engineering. So currently we are going to work in some software like SketchUp and the PVsyst software. So once you have the enough knowledge about those software, you can be like designer engineering. But when you are going to work in the site, there are going to be site engineering, solar site engineering. But the thing is good when you are going to combine those two, it will be so much good for you. So I'm taking this session now by the our institute. So the session it will be not that much long. It will be 45 minutes, and it will be introduction, only introduction class. So I'm trying my best to go very fast to cover everything for you. So I know the session will not be much enough, but I'm recommending everyone to try his best to join our full training. That training we are going to give full training about the solar system sizing and the design. Then we will do different type of project on grid project, off grid project, and hybrid project, and we'll do battery sizing also. So we can start right now. So in the solar system sizing and design, the first question is coming to your mind: what is the BV? What is the BV? Photovoltaic. So the BV means photovoltaic. That is converting the sunlight into the electricity. Okay. So this, as I mentioned, we have different type of project: on grid, off grid, and hybrid. So now we are going to know all the components or all the devices that's available in the solar PV system. We have the solar panel, the battery, the inverter, the cable. There's different type of cable: AC cable, DC cable, and earthing cable. We have the combiner box or string box, and also they used to call it DC DB box. Then we have the structure, LVS, lighting protection system, and number 8, the isolator, protective device. We have security system, we have the data logger, communication system, we have the automation, monitoring and control, we have bidirectional meter and zero export system, and the pyrometer and earthing and cleaning system. So cleaning system also it's a part of the automation. Okay, so let's go fast. This is our solar panel. Okay, it converts sunlight into electricity using the photovoltaic cells. We have the battery. As far as we know, the battery stores excess energy for the later use, especially in the off-grid system. We have different type of battery: lead acid, lithium-ion battery, flow battery, nickel-cadmium battery. So everyone is recommended the lithium-ion battery for the home. So, and even it is used to give more warranty years. Then we have the inverter. Inverter it used to convert from DC to AC. Okay. So as far as we know, the electricity is used to come through the panel. It is DC, okay. But and our home appliances, for example, if I want to charge this my AirPods, okay, you need AC, okay, electricity. So you cannot just directly charge it from the solar panel or even your phone, okay, if you want to charge your phone. So all the home appliances or most of the home appliances use AC electricity. Then we have the cable, the AC, DC, and everything cable. There's different type of cable. We have the combiner box or string box. Okay, let me show you here. Okay, this is the circuit breaker. This is the isolator. This is the failed protection device. Okay, this is the structure. The structure that means the the structure that the panel used to install on it. Okay, okay. Then we have the LBS lighting protection system, as you are seeing here. Then we have the isolator. Is the isolator is used to disconnect the power during the maintenance or emergency. When we have any, like we want to clean the solar panel, the solar module, then we are going to disconnect the power during that maintenance or emergency by stop the isolator or switch it off. The security system. So as far as you know, I'm not going to go in detail or deeply in the things. So it will be much good. I'm trying to concentrate in the simulation part. We have the data logger. Okay, it's used to record and store system performance data for analysis. Then communication system. Then we have our automation. Automation. So sometimes when you are doing big power plant, you need to do like monitoring and control. At that time, you need SCADA software or there are some other software. So then you can monitor and control your power plant. Then we have the bidirectional meter. So the bidirectional meter is only like measuring the electricity that's flow between the grid and the solar system. Grid means the government electricity. Okay, we have the zero support system. So let me tell you, in some project, like in the on-grid project or hybrid project. So for example, your home it used to use about 10 kilowatt in a day, okay? But your solar panel, it used to produce more than 10 kilowatt. It used to produce 12 kilowatt, okay? So there's 2 extra kilowatt. That 2 extra kilowatt, it used to go to the grid. This the system of like for on-grid system. But in case if uh, the solar panel, it does not produce any that amount it used to produce at that day there's cloud or wind just to give you about 8 kilowatt, so still you need 2 kilowatt missing. You are going to take them from the grid. Okay, sometimes the government are going to tell you actually take electricity from us but don't give us electricity, we don't need, we cannot pay for you. At that time you need to install the zero support system. It used to prevent excess solar power from the feeding into the grid. Then we have the barometer. It measures the solar irradiance and like sun intensity for the system efficiency. We have the cleaning system. So cleaning system is also a part of the automation. We have type of the system as you mentioned, on-grid, off-grid, hybrid. So on-grid is connected to the main electricity grid. No battery, use it. X energy can be sent it to the grid. Okay, and it is best for reducing electricity bills in area with the stable grid power. Actually, the disadvantage of this one, no power during grid out. Like if the grid is off, you are not going to like run your appliances. Why? Because there's a relation between the inverter and the grid. The signal for the inverter it used to come from the grid. Okay, that means if there is no any signal used to come to the inverter through the grid, that means we are not going to receive any electricity. Okay, so we have the off-grid system, completely independent, no grid connection. That when you are in the desert and you have power plant, at that time you are going to have battery and it is a bit expensive. Okay, no grid in this case. The hybrid system is combined from both the grid and off-grid system, but it's a bit expensive. And the disadvantage of this one is more expensive than on-grid system. Okay, I'm showing you the on-grid system. This is the sun, solar panel, inverter, net metering, home. This is the grid. Okay, this is off-grid system. In the off-grid system, you have the solar panel, charge controller. Actually, in some inverters, in the modern inverter, the charge controller it used to come inside the inverter. It used to feed your battery and home. This generator is optional. Okay. Then we have the hybrid system. We have our solar panel, AC battery, inverter, net metering, and home and the grid. As we say, hybrid is the combine of both grid and off grid. Okay, so please focus on this point. What is the GHI, global horizontal irradiance? So as when we put the angle, when we put the panel in angle, it will be good. And when it used to be like in zero angle, it used to be not that much efficiency. I'm going to tell you why. Because the irradiance, it will used to come and reflect from the panel or diffuse like that. So we always used to put what angle. So and we have something called GII, global incident irradiance. Okay. If we place the panel at a tilt angle, we can receive more irradiance, okay, or more watt. For example, we can get 1050 watt if we put it in angle like 20 angle, 21, 22, 22, 23, up to 25. It's not fixed. It's depending on the location of the area, okay? So may the sunlight reflect. So the final like radiation is GEI, global effective irradiance. We are going to take is 1020 watt. So that means we are losing 30 watt. But if we put it in zero angle, we are going to receive only 1000 watt. So now we are going to get extra 20 watt. So and that lose 30 watt is used to call IAM loss. Okay. So incident modified loss. Type of the panel, you have the full cell panel, half cell panel, tail cell panel. So now we need to know how to read the data sheet of the panel. There's important things. Okay. In every solar panel data sheet, we have the electrical data, mechanical data, and the temperature data. And we have the warranty data and packaging and operating data. In the electrical data, and this the most important data in the whole data sheet. SCC data, NOCT or NMOT, BTC, BSTC, CEC. So forget about all of that. We are going to focus on the SCC data. So the SCC is the standard test condition. Okay, for example, we have this panel. Okay, it has 5 different type of module. The first one it used to produce 720 watt, up to the last one it used to produce 740 watt. Everyone it has like specification. Okay, so the question is how they get this specification. Okay, I'm going to show you now. That's why they call it standard test condition. To get this data, they take the panel, just wait, sun simulation test simulation test machine. Okay, you know, guys, look to this machine, sun simulation test machine. This machine, after they produce the panel, they used to put it inside this machine and they used to give it 25 temperature and 1.5 air mass and 1000 irradiance. So this the data of each panel they get it. Okay. So please keep in mind, it's call it like a photovoltaic. In the whole solar system, you don't need temperature. You need only sunlight. When the temperature increase, the voltage decrease, and if the voltage decrease, it used to like make the system unstable. Like there's a lot of things is going to get missed. Okay, so let me just tell you what it is all. Vmax, the maximum what we can get it 720. Okay, VOC means open circuit voltage. That means what this the volt they got it when the panel is not connected to any load. Here we have the ISC. ISC is also short circuit current. If the current they get it when the panel is not connected to any load. Maximum power voltage VMBP. So this the voltage they get it after they connect the panel to the load. The same things here after the maximum power current IMPV did the current they got it after they connect the panel to the load. This is the module efficiency 23.2. That means the efficient FM of the module to convert the sunlight to electricity. Okay. There's there's a difference between string and array. This one is string. String is like a series of panels that are connecting together and we are putting them in one structure. But this the array. different type of string. So array is a group of string. Okay. Uh, please before we move, please keep that in mind. Okay. First, when you are converting from DC to AC, there will be 20 to 30% energy loss. So to go like to avoid that things, we should add 20 to 30% extra capacity, which is 1.2 or 1.3 times the required power. Okay, then please keep that in mind. Okay, we don't need temperature, we need only sunlight. When the temperature increase, the output voltage decrease, and when the temperature decrease, the output voltage increase. And always we need the voltage to be high. Second, to design any solar project, we must calculate the temperature data for the last 20 years. Minimum temperature, maximum temperature, average temperature. So when you are going to calculate the temperature, you are going to know how much volt you are going to get in different type of temperature. Okay, so this help to determine how many solar panels should be connected in one string. Okay, when to use SketchUp and the PVsyst software. We use SketchUp when the client, for example, I'm showing you now the SketchUp software. This is the SketchUp software. Okay, this one. This the Central Bank of Sudan. Okay, okay. We did not do any structure here. We just installed the panel in the rooftop. Okay, if you see. Okay. So sometimes the client will come to you, he will tell you, actually I want to install solar panel. And let's assume the client did the house of the client, okay? And you need to install two string, but you cannot install two string, the space is not enough. So that's why we use SketchUp to do the 3D design to ensure that is it possible to install that number of panel in the rooftop of the client or no. Okay. Then when we and we use the PVsyst only to run the simulation and analyze the performance and avoid any losses and shadow losses, temperature losses. Okay, that's all. So this is for the theory part. Okay, I'm going for you right now for the uh, design part and like that. So in this session, I mentioned that the PVC software, so everyone can download the trial version, like the student version. But I'm advising everyone who don't have even laptop to do the PVC software, the project on them. You can use the Excel, okay, Excel file. I'm going to show you. For example, this is the SketchUp as I show you. Okay, okay. Let me show you one thing, guys. How many panels we are connecting here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 means 20 panels in one string. Okay. I'm going to tell you why we are connecting 20 panels in one string. So okay, let's assume now we will do project. Let's do a project. I already did the project, but let's do it again. Okay. Okay. This project, let me show you how many panels also are connecting here. Let's separate it. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 10, 20 also are connecting 20 panel. As you see here. Okay. While installing our inverter and the combiner and string box here. It's our inverter. If you see inverter and combine and string box. Okay, this 100 kilowatt inverter. When you put our cable here down, you see. Okay, so okay, let me tell you. Just go to the PVsyst. Uh, did the project. I did the simulation and everything. Okay, guys, look here. This is the orientation. Once you want to do any project, first of all, you will come there. I will name the project. You will put the latitude and longitude, the coordinates. I mean, then you will come here. For me, I calculate the temperature. So I put the minimum temperature is 5 and it is impossible to get 5. But for the safety, if you have over voltage, it may have burned your whole system. Then I put the minimum, the average temperature is 40. Then the maximum 58 and the normal well 50. Okay. You don't need to know about those data right now. Later on, you will learn about them. Orientation. Always you have to make here down. Okay, you make the loose with the respect to the optimum 0.0 and transposition factor is 1 or 1.5 or less if possible. Look here, I select the panel to be tilt angle to be 18. Look, when I increase to 19, no problem. When I use to increase to 20, no problem. Okay, 22. Okay, now load with the respect to the optimum, like mean loose from the entire system is minus 0.1 and this one is get 1.05. So the best tilt angle is 18. Even 17 is not that bad. Okay, but I select 18. Why? Because when the angle will be like, for example, this is 20, 22, 20, 20, 18, 19, like that, 19, 18, when it will be 18, the shadow will be less between the one shade and another shade. Okay, so that's what we need always, the shadow to be less. Okay, so I'm pressing OK. Then this is the system. Here I'm selecting the panel 650 watt from Trina Solar. Did the module like is a bifacial module. Then the inverter. I select the grow watt new energy 100 kilowatt. Okay. So what I'm telling you, it has you can go from there and read the data for the panel data, SCC data, IMBB, MBB, everything. Okay, then you press OK. Even the inverter, you can read his data here. So just focus here, it's very necessary. Minimum MBB voltage is 180, and you have the most important is nominal voltage. That means 600 volt. Means if you want to get the full efficiency from the inverter, you have to give the inverter 600 volt at the whole time, like in the minimum temperature, maximum temperature, average temperature. The inverter should always have this voltage amount of volt. Okay, so the maximum volt it should get into the inverter is 1100 volt. Okay, I'm showing you now. When my temperature is 58, I used to get 33.2 volt. When my temperature is 5, I used to get 47.8 for one panel. This data for only one panel, okay? So this inverter had come here. It has 10 MBBT and 20 input. That means every 1 MBBT had 2 input, okay? So I connect 20 module in series and I have 10 steering. I'm not going to connect 20, no, only 10. I will tell you why. So that show me here when the temperature is 58.58, I'm going to get 664 volt. And when it is 40, I used to get 711 volt. And when it is 5, I used to get 9.955 volt. That means I am always in the safe side. You know why? Because I did not cross those limit, and also I give the inverter the nominal voltage in all the time in the different type of temperature. Okay, so uh, if the binom ratio 1.3, as I told you, it should be between 1.2 to 1.3. We are give the exact one 1.3. Okay, after you click OK, you click OK. There's another details like the project is free mounted, okay, or it is in the rooftop like that things, but we don't want to go deeply. There's not that much enough time. We have the soiling laws, okay. We have the AM laws, auxiliary, egging, everything we are going to learn it in the full session, okay. So then we have your self-consumption and storage. No need for those posts, okay. We have the horizon, okay, sun direction, near shading. With the near shading, you will draw the panel. Let me do the shading animation for you. Okay, look. Here we are doing the shading animation. If you can see, you draw the panel there and everything. This is going to give you a report. Okay. Then module layout, how we distribute the panel. So as you see here, okay, that's panel. Okay, as you see here. Okay, let's go back to the PVsyst. The same things. The first string, second string, third string, fifth, sixth, seven, eight, nine, 10, 10. Okay. Same. I distribute all of them like that. Okay. Then we'll go to the run the simulation. After you're running the simulation, it will give you some report. Okay. Cool. So guys, if someone you wanna do research paper or anything like that, he can use the PVsyst. If you just go and read some publishing research paper, you will find a lot of research they have been publishing them through the PVsyst related to the solar. Okay, system board is 780 kilowatt. Okay, this some data. Okay, you don't need to know about them right now because this session is a bit free. This is like the drawing of the solar panel to do the shading analysis. So this is the performance ratio. It used to go up to 0.8 sometimes. This is normalized productions per installed kilowatt power. So here the balance and the main result. Okay. Okay. Then we have the loose diagram. The loose diagram. We have those loose module degradation loss for real 10. BV loss due to the irradiance levels. So it's not that much. BV loss due to the temperature minus 8.87. Module quality loss like that. Then the most important things here. Inverter loss during operation efficiency is minus 1.48 because we are installing the inverter in the it's not in the room. It is installed under the structure. It will get affected a little bit with the temperature. Then inverter loss over nominal voltage is 0.02. Okay, because we give the nominal voltage the amount that used to take no much loss here. Inverter loss due to the max input current, no any loss. Inverter loss over nominal inverter voltage, no any loss here, you see. Inverter loss due to the port threshold minus 0.1. Inverter loss due to the voltage threshold is also 0.0. Night consumption 0.0. So that's the most important things here. Okay. So this is some graph. It's a bit hard to go through them. This the single line diagram. Single line diagram shows how the connection is going to be. With the panel, then the combiner, then the inverter, the injection point. That's all. Okay, the important things. Uh, this carbon, okay, CO2 emissions balance, showing you the how much CO2 you are saving, like that. Okay, this actually this financial analysis, it show you like in the by the green one, it show you how you are going to like get the profit from your project if you are going to sell electricity from the for the government only. Okay, and this the lose maybe for the 7 or 6 years first, you're not going to get any benefit, but after that, the amount of money you're going to get is too much. So now I want to show one thing is necessary. When I use the PVsyst, it show me like no need to know how many, no need to do any calculation by my own. Everything is almost done. Everything is almost done by the PVsyst. But now this file, Excel file, I used to call it the $1 million file. Okay, if you have this file, you can do any project. First of all, you have here latitude and longitude. This is how you're going to find them. You are going to come here, go to the map. After you go to the map, any place in your mind, it's not a big deal. Let's assume I want to do project here in this rooftop. Okay, you're going to select this one, right click, uh, click on it. That means you copy it. You will come here, you will do it. You are copy. Then take this one. Okay, nice. Then in the SketchUp, again you'll put the PVsyst, the coordinates here. Then this the Google Earth data. Then here for the design in the SketchUp. Okay, everything, the azimuth, the tilt angle. Okay. Then we have the what you call the PVsyst Excel SketchUp like volumetric. Okay. So for this one, even let's try to like don't put that much pressure on us. I don't want to take that much time. Then we have the minimum temperature, maximum temperature, average temperature. This from the weather data. We assume the minimum temperature 6, maximum temperature 5, average temperature 27. We are going to do what? So test and check the shading analysis. Okay, in the shortest day in the year, which it is 21 December, and in the longest day in the year is 21 June. Then we have the design. Okay, in the SketchUp we have the pitch and IRSD. So I'm showing you what is the pitch and what is the IRSD. Okay, I'm showing you. Just wait. Okay, guys. Okay, from here to here, this one. This is called the pitch from this one to this one. Okay, but from here, from for example, from here, the end of this one. Zoom is for you. From the end of this panel to starting on this one panel is called the IRST. You are going to put the distance to write the distance between them. Okay. Module capacity. Okay. Plant capacity, number of modules. Okay. This also you'll put them. Okay, I'm telling you now. In the last time I told you this STC data and I tell you VOC, VMBB, ISC, okay? We will took this data, okay? And let me show you. I just want to download any datasheet for you, then it can be easy. Okay, guys, look to this panel, okay? This is the electrical specification. This is the data, okay? You have the VMBB, you have IMBB, you have VOC, all they told you as STC, standard test condition, okay? You have something that is very necessary. Maximum system voltage means like let me show you. Okay, the system told you that for in 5 temperature we are going 47.8 volt from each panel. Okay, oh, and that's what means 47.8 multiplied by 20 panel. We are going to connect 20 panel in series 9.56. We are going 9.55. Not a big different one. Okay, so that means we did not cross the maximum voltage. But let me show you for this panel, we are going here to win. Let's see the maximum system voltage. I hope I am going to find this one here. Okay, I don't find them, but if I download this module, I can find it later, okay? But no problem. Let's go to the okay. The maximum system voltage 1000. That means you cannot connect more than 20 panel outside. I calculated in here, okay? We still under 1000 by 50. We did not cross it, okay? So we have module series views 15 ampere, okay? Number of dials 63. This one don't go deeply too much, okay? Just I'm going to tell you. We need to know how you are going to operate this system. Let's go back to the Excel. This is the data, okay? Okay. So we put the data here, okay? Let's hold the data. System voltage. For this is another data for another project, okay? So on our inverter, it is like I think 100 kilowatt inverter, okay? So now I'm going to show you how you are going to calculate the mm, maximum voltage and average voltage and minimum voltage, okay? First of all, minimum temperature minus SCC temperature. The minimum temperature here is 5, okay? You are going to click here. 5 minus, if you see, this one, 5 minus 25 is equal to minus 20. Then we have to temperature coefficient VOC minus no divided by 100, okay? This means temperature coefficient, this one, TKVOC, okay, and it's multiplied by VOC, this one, divided by 100. We are going to do that. TKVOC multiply by VOC, okay, we get this amount, okay. Then step 3, step 1 into step 2, step 1 into step 2. That means this one into this one, okay. We're going to do this one into this one, okay. So step 3 is equal to step 3 plus STC VOC. Step 3, this is step 3. Wait, I have to put the equal sign here. Equal to step 3 plus SCCVOC, SCCVOC. Okay, we are going to get 34, 43, uh, uh, 43.575 volt from each panel. That what does mean? That means we are going to connect 22.9, and you know you cannot connect zero point 0.9. You are going to connect only 22 panel in series. So when you are going to connect 22 panels, you are going to get 958 volt. When you are going to connect 18 panel, you are going to get 784 volt. When you are going to connect uh, 16 panel, you are going to get 697 volt. That means you're still in the mode of save of the nominal voltage when we did not cross the 1000 volt. This one the inverter volt. Okay. Here in this case, for the maximum temperature, the same things I did it here. We will do it. We will just follow. We say the maximum temperature 55 minus SCC temperature 25. We get this 30. We will follow it up to here. We will get 30 volt. That means it's ask you to connect 27 panel. Okay. When we are connected 27 panel, 27, 57 panel, we are going to get 834 volt. That means we are near to the inverter amount. That one. Okay. So when we are going to connect 25, we are going to get 772. So same thing here for average temperature 22. When we do the calculation, 22 minus 25, and we'll do the same step 1, 2, 3, 4. That means the minimum volt you are going to get is 35 volt, 34 volt in each panel. That means when you are going to connect 20 panel, you are going to get 695 volt. Okay, and when we are going to connect 25 panel, we are going to get 868 volt. So what do you learn from this one? You learn that if you don't have the PVsyst, you can work in this SketchUp file. Okay, but you need to have this as file. And no one, I'm recommended everyone to join the 1 week training session. Then we can learn it online one by one. Everyone is going to do those projects in front of me. Then we still have something we need to know about it. The MBBT. If you remember, I told you MBBT had two tracker, one tracker. You are going to know what is the MBBT. I'm going to show you a picture. You need to know all of those connections. And this may be the bus bar. Okay. Okay, I'm going to show you another one. Uh, okay, look guys. When you are doing any project, you have to make it like a little bit arrangeable. Like you put the location, latitude, longitude, type of the project on grid inverter. Okay. So then you have to put the module name, the weather data. Okay, minimum temperature 5, this 40, 58 as I told you. This the inverter data, minimum volt, maximum DC voltage, MBBT voltage 180 to 1000, and nominal voltage. Okay, this is the panel data, VOC, VMBBT, IMBISC, TK, VMAX, TK, VOC, everything you need to know. Listen guys, those they're important. Why? To calculate the temperature. Okay, then we have the maximum volt I got, the minimum volt I got, average voltage I got. You know, I'm not did this from my mind. There's some formula here, we need to know it. I don't want to go deeply as I mentioned. It's very tough to show you those formula and how you wrote them. Then maximum voltage from 22 panel 956 volt, minimum voltage, average voltage, maximum current, short circuit current, like that. Binom ratio 1.2, 1.3, MBBT AC, MBBT AC 10 kilowatt. We're going to add more 12 to 13 kilowatt, like that. So the number of the panel In this case, if you want to add binom ratio 1.2, it should be 18 panel. But if you want to give 13 kilowatt 1.3, you have to add 20 panel. And I select 20 panel. Okay, look here, guys. So this is my inverter. My inverter has 10 MBBT, 20 input. This means every MBBT had two input. This input, this input. Okay. We are not going to use the the two input at the same time. So we are going to use only one input, and we will make the another one to be like free. Why? For the safety purpose. If there's any issue happens in this, like in a point, we are going to remove it to this point. Okay. So that's the meaning of the MBBT and the tracker and the steering connection. Okay. Let me show you. This, for example, this is my first string. It's going to connect positive to minus positive in series like that until I'm going to connect it to the inverter one. But you need to make everything professional, as I mentioned. You are going to take a wire from here and okay, let me do it again. From inverter up to the first string. It's showing you like how like the links. Okay, that links. Wait. Okay, this links. For example, is 50. Wait, from the first one. It show you first one is 58 meter. Okay, and like that you are going to calculate every string from the string to the inverter, and you know how like the distance of the wire. Then you can tell your client to give you which wire and the like the distance of everyone. So after that you need to do what? You need to do the average, the calculation for each one. Okay, so every inverter has 10 string. Every string, the distance from every string to the inverter we are going to calculate. Then this is the list component. Okay, solar PV panel. Okay, this is the module quantity. We need 1200. So one means the watt. 1 watt is 18 taka, for example. So 18 multiplied by the watt of the panel is 650. You are going to get the number by rate of the country, or then you can convert it to the dollar. So guys, that's all. I take you like, yeah, I really skip some data and some important point, but you know the session was a bit short, so that's why I don't want to make it complicated. So I hope I've been showing you an enjoyable. So finally, I want to mention that for everyone, I'm recommended, and I really tell everyone from the deep of my heart, if you can join the full training session, it will be nice. We will teach you how to do the 3D design. Second, I will teach you to how to master the PVsyst software. Then, if you face any issue in the future regarding to the any project, like we will give you a support and we will try to solve those issue for you. So thank you for watching this session. So please, if you have any question, you can ask me, or I will put this session in the Google Classroom. You can write your comment, and when I saw the comment, I will reply for you. Thank you for everyone.